Hello everyone, this is the coding teacher, and today I'm not going to get into any coding. Today I'm going to talk about how to structure your studying in order to pass the typical software engineering interview at a FAANG style company. Right now we're in the middle of this coronavirus pandemic and people are getting laid off left and right, yet some of the strongest companies like Amazon are still hiring. And as mostly any engineer knows, FAANG company interviews are heavily based on data structures and algorithms. So now if you've been laid off, sorry to hear that. But at the same time, it's a great time. It's an opportunity to start brushing up on these topics. It's a good time because you have extra time since, if you've been laid off, you don't have a job. And depending on where your programming skills are at, it may take as little as 100 hours or so to be FANG ready. The reality is that all these big, powerful companies are still hiring thousands of engineers. They pay better and have better working conditions than all the shitty startups that hire you without knowing data structures. These shitty startups are folding like flies too. The VC environment is dried up, and it really has never been. There's never been a better time to have strong foundational computer science skills. But why should you listen to me? Well, I actually work at a FAANG company. I'm a team lead at AWS, and I have coached a couple of people before who have told me that my coaching was instrumental in helping them go from a state in which they couldn't even pass phone screens to a state in which they were not only passing most phone screens, because phone screens are usually pretty easy, but they were actually landing offers at about half the on-sites where they went. I've actually also done over 1,000 software engineering interviews in my career, and have a pretty good knack for knowing how an interview is supposed to go and what employers are looking for. But I gotta be honest though, there's no secret sauce. Okay, it's gonna be some hard work. And the good news is that being on the inside, I can really guide you and tell you what to invest your time on and help you not spin your wheels uselessly. And that's a mistake a lot of people make. Here's the thing. There's a lot of topics in data structure, right? So you can start studying something like hash maps, for example. And then you go really, really deep in there and then you start learning about Bloom filters and tree maps and about how to make hash maps thread safe and so on. And at that point, you're already way past the point of diminishing returns on this topic. You're spinning your wheels. This is a mistake a lot of people make. What you need to do instead is set a strong foundation of the basics, a strong layer of foundation of basics. And because what happens if you're a hash map guru, right? And then you go to the interview and they don't ask you anything about hash maps, you fail, right? You should be approaching your studying in layers. Become equally proficient at all the topics that I'm going to give you, and then once you have those mastered, only then move on to more advanced topics and move on to more diverse practice. Okay? So without further ado, here goes my list of essential things to know in order to have a chance at passing the data structure side of the coding interview. Essential topic number 1, data structures. You have to actually understand the basic data structures. You have to understand the stack, queue, linked list, binary search tree, and hash map. Okay, what does it mean to understand a data structure? Number 1, you have to know the interfaces by memory. You have to know stack is push pop peek, boom. Like by memory, they wake you up at 3 in the morning, you can rattle off the interface. You have to know the broad strokes of the implementation of each of these methods by memory. The broad strokes. Don't necessarily have to know all the corner cases and all the alternative implementations. Know one. And number 3, you have to know the time complexity of each of these operations in the interface of the data structure. Okay? But this you should not know by memory. You should know the time complexity of the operations because you understand time complexity. And that's my second topic to study, time complexity. This is actually a difficult topic to master, especially because most of the explanations online are just a bunch of mathy bullshit where the teacher is just regurgitating some formula, all this ethereal crap about epsilon and omega, and you can tell they don't even have a clue about how this applies to the real world. And if they do, they probably don't have a clue. Usually don't have a clue about how the math connects to the actual practicalities of it, right? So I can tell you for sure, you can forget about all the math. You don't need to know that epsilon and omega bullshit. And here's how you actually learn time complexity. As you're studying an algorithm, for example, you're learning in order reversal for binary search trees, right? So you look at the algorithm, you look at the pseudocode, and ask yourself, what is the time complexity of this, right? Think it through, put down your answer, and then look it up. If it was correct, then make a mental note about it. But if you were wrong, then that's when it's really important to spend some more time reflecting on why you were wrong. So reflect on what the solution is, what was the correct reasoning, and why your reasoning was wrong. Then the next topic to know is recursion. Okay, so recursion is always the same. It sounds the principles are very, very simple. You have a base case and then you have a recursive call, right? If you're multiplying all the numbers in an array using recursion, your base case would be if the length of the array is 1, return element number 0. And then your recursive call would be returning the first element of the array times a recursive call on the rest of the array starting at element 1. So if you think through how that's going to go, basically what it is you have a base case that always returns something when the input has shrank to a certain level, and then your recursive call shrinks your input so that eventually it will get to the level that the base case is looking for. Very, very simple, but I know it's not easy because I remember struggling with it in college for a long time, and I remember being very tripped up by it, and until it didn't click, and it was mystifying to me. So what you got to do is think it, reflect it, and practice it. What are some great ways to know that you've mastered recursion? Like if you understand, if you've memorized and you can implement merge sort code, that's a great sign. If you can understand and implement all the tree traversals code, that's a great sign. Okay, so try to focus on those in order to help you understand recursion. The next topic, common array problems. So array problems pop up all the time in programming interviews. Some of the most common array problems are: 1, counting occurrences in a list with a hash map. 2, finding minimum or maximum element in a list. Finding the minimum or maximum sum of 2 elements in a list, or of 3 elements in a list, or of 4 elements in a list. And then there's a variant of this one, finding the minimum or maximum difference of 2 elements in a list, of 3 elements in a list, of 4 elements in a list. Another one is finding the mode of a list, the most frequently occurring elements, right? There's a couple of variants of that. Those are some problems that you should be able to solve like that quickly. Then 2D arrays is another topic that you have to master. Nested loops should be like second nature to you. You should be able to convert x and y coordinates to a one-dimensional array index and back very easily. And this is just a trick that requires a division and a mod operator. And then I actually think I have another video where I explain it. Then next topic, tree traversals. I already mentioned them before during recursion, but you should know all the tree traversals cold off the top of your head. Recursion is useful for in-order, pre-order, post-order traversal. And then there's the level order traversal, which is basically the same as breadth first search. So know that off the top of your head. Then the next topic to know is breadth first search. So breadth first search doesn't necessarily have to be with binary search trees. It can actually be with any type of graph, and you should understand how to do breadth first search. Once you've mastered that, the next level, once you've mastered all your basics, the next level would be doing breadth first search with cycle detection. And then final topic is anagrams. So this is another topic that's great to test your understanding of recursion that comes up in lots of software engineering interviews, right? You have a string, and then you got to come up with all the possible permutations of characters that are in the string. And then, maybe do something else. Maybe figure out how many of those are actual words. Check them against the dictionary or whatever. But this whole thing of coming up with all the potential letter combinations of a string is a very frequently occurring problem in software engineering interviews. And so those topics should be your high-level guide to setting a strong foundation on algorithmic problem solving. The next step after that is actually practicing LeetCode-style problems. Okay, so what I'm going to do next is pick out a selection of medium-level leet codes, each of them dealing with one of these common foundational topics, and I'm going to give a 5-minute explanation on how to solve them, and then provide the actual implementation of a solution. That's going to take longer than 5 minutes. The implementations, though, you should only use them as your reference, right? You should look at the explanation you should look at the leet code first, try to think about how to solve the problem for at most 10 minutes, and if you haven't come up with a solution that you're very confident about, then go ahead and look at an explanation, mine or somebody else's explanation, right? And once you've looked at an explanation of the solution, memorize the broad strokes of the solution, okay? Finally, go ahead and implement it, okay? So that's my process for going ahead and tackling your leet code practice. First, read the problem. Second, think about the solution. Third, if you can't find a solution within 10 minutes, look it up, right, and memorize the broad strokes of it. Fourth, implement it. By the way, this is based on the whole, this process has some basis on neuroscience and some other things that I've learned by reading books like Make It Stick, the Peak, the Coursera course on learning how to learn, a bunch of resources on how to help people train and learn more effectively. And that's the reason why my videos will focus on explaining the concept behind the leak codes in 5 minutes or less. So you can get the general idea of how to solve them. And then once you have solved about 100 leak codes, by the way, like if you're an experienced programmer, at that point, skip the implementation and focus on being exposed to and memorizing as many solutions to leak codes as your time allows. Okay, but remember to cover the basics first. Even if you're an experienced programmer, cover the basics first. Cover the topics, be good at the topics that I listed before, because going straight to leak codes without knowing anything about data structures is like trying to run before you can walk. Okay, it's Karate Kid in this motherfucker. We gotta wax on, wax off first. That comes first, basics first, and then go ahead and do your drilling practice. So that's it for today. Thanks a lot for watching, and if you found this useful, please like and subscribe.